Okay, so I think I can get this done in just one more 10-minute video. Okay, so the other thing, so I wanted to show about the best way to get information to us and get things back to us is to write an inbox message to all teachers. My email is very busy, gets really full with lots of stuff, and sometimes that can slip through the cracks. We have an assistant teacher with us, Heather Johnson, and she will meet with me 4 times a week to make sure we are on track with all the students getting their needs met, getting grading done in a timely manner. We try to get better at that every year. It's still something that's difficult with me. I get too excited about the stuff to get the grading done, but she's going to be on it 4 times a week, and the best way to do it, to get in touch with us, is not to email me directly, but to go up here, and it's only showing Heather Johnson because she's the only person on this class now, but write something to all teachers. When you send it to all teachers, it will come to Mrs. Johnson and to myself, and it will get on her list. And also, I have set up in my haiku so that these things get sent directly to my phone, as there's a text message alert when you send me an inbox. That's not the same for my email address. I do want you to have it and keep it forever. You can always contact me years later. I would love to hear from you, but this will text me and let me know that, hey, there's an issue, and Heather will get that to make sure that even though I saw it, that I remember to follow back up on that. So that is the best way. Now, the class is set up so that students can send each other inbox messages as well. We like to promote peer-to-peer communication as much as possible. If at any time this becomes an issue for anybody, unfortunately, I will remove that option for everyone. So we expect professional communication. This isn't a matter of dumbing something down or treating kids like kids. I expect the students in this class to communicate with each other as any adult would with their colleagues, which means, professional courtesy, and, doing things in a usually a supportive way. And if there are any problems, please let both of us know immediately about that. Okay. There are a lot of concerns and worries about the math, and I just want to rest, so hopefully make some people feel a little bit better, and I really want you guys to relax about this. This class will be, if you've already taken Algebra 1, this will be great. If you haven't, if you're currently taking Algebra 1, you might need to learn a few things a little bit out of order than you're going to learn them in Algebra 1, but this will be a great supplement to that. And if you're not yet in Algebra 1, don't worry, I can set up some side times and we can go over some stuff to get you just the few particular concepts that you're going to need. You're going to need to learn to move things from one side of an equation to the other. The way we can, that basic steps in Algebra 1 to move things from one side of the equation to the other. In particular, make sure that you have covered what to do when a term is squared, because we are going to derive E equals MC squared together as part of our homework, and so you'll need to move that around. There's a very interesting thing about this squared term as well that Dirac had to notice, and it comes from basic Algebra 1, and it points to a whole new set of particles. So that Algebra 1 is important stuff. What you will lean upon the most in this class is the equation of the line. And equations of a line, you may have seen, if you've already covered Algebra 1, you will have seen it as y equals mx plus b. If you've never seen that before, I will do one-on-one with you and teach you about y equals mx plus b and why that's exciting. We're going to use that in order to help you guys navigate in space-time using something called a Minkowski diagram. And believe it or not, it is straight lines using y equals mx plus b. We will also talk about the fact that there's a different way of saying exactly the same thing, and that is something called a function. And instead of y, we say a function of x is equal to mx plus b. So if you've seen that before, or if you've seen functions of functions, that will be a big help. You will learn and use some basic calculus. Now, we're going to do integrals and differentiation, but we're not going to do them for curves unless you want to meet with me outside of class. We're going to do them for our straight lines, but we will learn the meaning behind calculus. We won't go into, if some of you are more advanced, we will not be covering the fundamental theorem of calculus, but if you want to go into some of that with me one-on-one or in office hours, that would be great. The basic calculus will just be off of straight line. The most complicated thing you have to do is find a slope of a line or find the area under a triangle. We will understand some general ideas about some things called, in field theory, called div, grad, and curl. And so if you have technical people, engineers in your family, and you tell them, I'm going to be learning about div, grad, and curl, they will say, what? That's insane. We're not going to have you calculate and do the math with them, but you're going to learn about the meaning of them and use them in something called field theory. There will be some trig. If you've taken my Aristotle Leads the Way and my Newton at the Center class, you've already done most of the trig you will do in this class. If you've never done any trig, don't panic. There's a secret for you. Trigonometry sounds really complex, but secretly all it means is measuring things with triangles. And we will walk you through it. It's just triangles, but you'll be able to say, oh yeah, I did trig today. At the end of our class, we will be working on something called Schrodinger's wave equation. You will not use Schrodinger's wave equation and do the actual calculations yourself, but what we're going to have you do is understand what each operator is doing in Schrodinger's wave equation and what the whole equation together means. And it's really cool. It combines all these things: calculus, field theory, probability, which we'll cover a little bit in class, and some trig, and it does some crazy, crazy things. This class is going to be so the math in this class is going to be easier. People think that will be the hard part, the math and the physics in this class. There is a hard part to this class, and it has to do with why MIT is pass-fail. So a lot of people are attracted to this class because I did attend MIT, and I was surprised that the freshman year is always pass-fail and has been for many, many decades. And the reason why is that the number one fear for gifted kids, no matter whether you're a gifted kid at your age level or a gifted kid who's just arrived at MIT for their freshman year, or a gifted kid like me who's 48 years old, the number one fear, or one of the biggest ones for us, is something called the imposter syndrome. The imposter syndrome, which is this fear that if I show that I don't know a thing, that's going to be really hard. I would say this is the hardest part of this class. And the reason why MIT keeps their first year pass-fail is that for many students who arrive at MIT for the freshman year, it will be the very first time they have encountered something that they couldn't learn immediately. We will be discussing Einstein's paper, and it's important to understand that Einstein himself got some of the implications of his own work wrong. We'll be talking about his discussions with Niels Bohr on that, a lifetime of debate about what his own work meant. But if your student has never encountered something really difficult, this is a very tough thing to go through. But we will talk about that I have magical MIT admissions powers. At MIT, they say that the admissions department is the only infallible department. And that means that, students hit that imposter syndrome. They say, oh, they made a mistake. I don't belong here. Nope, it just got hard. But I have magical admissions department powers, and none of my students are imposters. It just gets hard the first time you run into that. So okay, we do have assignments. I think I covered that. It's just a check grade. Haiku inbox, we covered that. There is something called spamming the chat. Sometimes when people get excited about concepts, or they get bored, or they just need some stimulation, they'll start filling the chat with random stuff. It's okay to have occasional comments back and forth to each other that aren't related to class. That is acceptable. But don't fill it up with random characters, because I need to watch that chat to see questions. I do like to hear students talk and ask questions in class. Please make sure that your student has earbuds for that, because if they don't, even if they're using their laptop's microphone, especially if they're using their laptop's microphone, we'll get feedback when we try to talk back and forth about that question, and that can make it a really unpleasant experience for them asking a question and really being heard. But try to think about a 3-comment question answer rule. Some students need there to be that silence in order to feel like they can answer themselves. So I will ask, I'll open a question, and if you've already answered or whatever about or commented about 3 times, try to wait a good long time. And you might, I have a couple students returning who do this really well. They might say in the chat, "Oh, I know it. May I say the answer?" And then I'll say, "Oh, yes, I'm." But try to leave that empty space for others. Okay, that.